Imagine this. You flip a light switch in a dark room, and within a fraction of a second, the entire room is bathed in light. It happens so quickly, so seamlessly, that we hardly stop to appreciate the marvel unfolding right before our eyes. What we're witnessing in that moment is the astonishing speed of light, nature's ultimate speed limit. Light travels at an incredible 299,792,458 meters per second, or about 186,282 miles per second. To put that in perspective, if you could travel at the speed of light, you'd be able to circle the Earth 7.5 times in a single second. That's faster than the blink of an eye, faster than any car, any plane, or even the fastest rocket mankind has ever created. It's almost unfathomable. But why is light so special? And how do we even know how fast it moves? Let's rewind to the 17th century. For much of human history, people believed that light traveled instantaneously, that it moved so fast it had no finite speed at all. It wasn't until 1676 that a Danish astronomer named Ole Romer made the first measurement of light's speed. He did so by observing the moons of Jupiter through a telescope. While tracking the moon Io's orbit, Romer noticed that its movements seemed to vary depending on the distance between Earth and Jupiter. He deduced that this was due to the time it took light to travel across the increasing or decreasing distance, proving that light, in fact, had a measurable speed. From there, scientists like James Clerk Maxwell, Albert Michelson, and others refined Romer's work, eventually zeroing in on the exact value of light's speed. Today we know it so well that it's even used as a defining constant in modern physics. Now here's where things get even more mind-blowing. The speed of light is not just fast, it's absolute. According to Einstein's theory of relativity, nothing in the universe can travel faster than light in a vacuum. It's a cosmic speed limit dictated by the very fabric of space and time. And when you approach light speed, everything changes. Time slows down, distances shrink. Reality itself behaves in ways that defy common sense. Take a moment to imagine what it means to see the sunrise every morning. The warm hues that fill the sky. Those photons, the particles of light, traveled roughly 93 million miles from the sun to reach your eyes. And yet, despite this enormous distance, they made the journey in just over 8 minutes. 8 minutes! That's how fast light works. It's the universe's way of ensuring we're still in touch with the cosmos, no matter how vast the distances may be. But light speed isn't just a celestial wonder. It's also the foundation of countless technologies we rely on every day. Think about the internet, for example. When you send a message, the data travels as light through fiber optic cables. Or GPS, which relies on signals traveling at the speed of light to pinpoint your location. Even movies about space exploration, like those dazzling visuals of warp-speed starships, are inspired by what we know about light's incredible velocity. And yet, for all its speed, light has limits. Light from the sun takes 8 minutes to reach Earth, but sunlight itself is over 30,000 years in the making, created in the sun's core and slowly moving outward through dense plasma before it finally escapes. And when you look up at the night sky and see the twinkling stars, you're not seeing now, you're seeing the past. Light from those stars has taken years, decades, sometimes even millennia to reach us. The farther away the star, the older the light. It's like peering back in time, a natural time machine written in photons. Perhaps the ultimate legacy of light's speed is what it reveals about the universe itself. The vastness of space, the beauty of the stars, the intricacies of physics, all of it comes down to one simple truth. Light moves fast, unimaginably, incomprehensibly fast. And yet, it's bound by laws that we can study, understand, and marvel at. So the next time you flip a light switch or gaze at a star-filled sky, take a moment to think about what you're truly witnessing. Light racing across unimaginable distances, painting the world around us in vibrant, visible color. A speed so vast that it allows us to explore the universe, communicate across the globe, and even glimpse the deep past. It's not just fast, it's not just fascinating, it's the ultimate testament to the wonder of our universe.